Welcome to the definitive guide on COBOL data types. Understanding COBOL data is crucial for robust business applications. We will explore each type in detail. Then, we will clearly map them to DB2 SQL data types. This will help you build efficient and error-free mainframe programs. Section 1. COBOL data types. The basics first. Let's cover COBOL's core data definition tools. The picture clause is fundamental. It specifies data type, length, and format. It tells COBOL what your data looks like. The usage clause defines internal storage. It impacts efficiency, especially for calculations. If omitted, usage's display is the default. Alphanumeric data, PIC X. Let's start with PIC X for alphanumeric data. It is COBOL's most flexible type. It can store any character, letters, numbers, symbols. Each X equals 1 byte of storage. Use it for names, addresses, or product codes. Any string where no arithmetic is needed. Data is left justified. It pads with spaces if shorter, truncates if longer. Example: 05WS, customer name PIC X, 50. This holds up to 50 characters. Numeric display data, PIC 9, next, PIC 9 for numeric display data. It holds only digits from 0 to 9. But it is stored as characters, not true numbers. Each 9 also uses 1 byte. Use it for IDs or postal codes where numbers are not computed. Data is write justified. It pads with leading zeros if shorter, truncates if longer. Signed numbers use S, like PIC S9, 7. The sign is usually an overpunch, not a separate byte. An assumed decimal uses V, like PIC S9, 3, V99. The V takes no storage. For explicit sign characters, use sign is separate. Warning: arithmetic with PIC 9 is inefficient. COBOL converts it for calculations, then converts back. Alphabetic data, PIC A. Alphabetic data uses PIC A. It is restricted to letters A, Z and spaces only. Any other character is an error. Like PIC X, each A uses 1 byte. It is rarely used today, as PIC X is more flexible. Example: 05WS, state PIC A, 2. Edited display data. Edited display data is for formatting. These types are for generating reports or screen output. They cannot be used in arithmetic operations. Common editing symbols include Z for zero suppression, asterisk for check protection, dollar for currency symbols, for comma separators, for actual decimal points, plus, crossing, DB for signs. Example: PIC $ZZZ, ZZ 9.99 formats currency. Editing happens during a move operation. Computational data types, numeric, NULL, for efficient arithmetic, computational types. These store numbers in machine-readable formats. They are much faster for calculations. Packed decimal, comp3, is highly common. It stores 2 digits per byte. The sign is in the last half byte. It is very efficient for financial calculations. Example: 05WS, total sales, PIC S9, 9, V99 comp3. This stores 11 digits in 6 bytes. Binary data, comp4, binary data, comp or comp4 or binary, stores numbers in native binary. It is incredibly efficient for integer arithmetic. The byte size depends on the picture clause. S9, 1, to S9, 4, typically 2 bytes, like a SMALLINT. S9, 5, to S9, 9, typically 4 bytes, like an integer. S9, 10, to S9, 18, typically 8 bytes, like a BIGINT. Use it for counters, array indices, or flags. Example, 05WS loop counter PIC S9, 4, comp. Floating point data, comp1, comp2, floating point data, comp1, comp2, uses scientific notation. Comp1 is single precision, 4 bytes. Comp2 is double precision, 8 bytes. These are for complex scientific or mathematical calculations. They are less common in typical business COBOL. Comp3 is usually preferred for exact decimal precision. Group data items. Finally, group data items. These are collections of elementary items. A group item has no picture or usage itself. Its length is the sum of its parts. They logically structure related data, like a full employee record. When a group is moved, it acts like a single PIC X string. All its internal fields are moved as raw characters. Example, 01WS customer record. This is a group item. 05WS customer id PIC 9, 7. Section 2. COBOL data types mapping with DB2. Now that we understand COBOL data types, let's see how they connect with DB2. Accurate mapping is essential for smooth data exchange. It prevents errors and ensures efficiency. When interfacing COBOL with DB2, you need to choose the COBOL type that best matches the DB2 column. Mismatches cause big problems. We will cover the optimal mappings for common types. First, a quick look at common DB2 SQL data types for reference. These include SMALLINT, integer, decimal, char, and VARCHAR. Mapping alphanumeric, PIC X, for COBOL PIC X, N, alphanumeric strings. Directly map to DB2 char, N, for fixed length data. Example, COBOL PIC X, 8, maps to DB2 char, 8. For variable length strings, map to DB2 VARCHAR, N. COBOL needs a special VARCHAR host variable structure. This includes a length field PIC S9, 4, comp, and a text field PIC X, N. Mapping numeric display, PIC 9, for COBOL PIC 9, N, numeric display. If it is purely an identifier, map to DB2 char, N. Like an SSN or phone number. If it is a true number, map to decimal, P, S, or integer. COBOL PIC S9, P, V9, S, directly maps to decimal, P plus S, S. Example, COBOL PIC S9, 5, maps to DB2 decimal, 5, 0. COBOL PIC S9, 3, V99 maps to DB2 decimal, 5, 2. Mapping alphabetic, PIC A, COBOL PIC A, N, alphabetic. Typically maps to DB2 char, N, or VARCHAR, N. Remember, PIC X is usually better in COBOL. Mapping edited display data is for formatted display within COBOL only. These have no direct DB2 equivalent. The underlying unedited numeric value maps to decimal, integer, etc. Formatting is applied after retrieving the data into a COBOL program. Mapping packed decimal, comp3, for COBOL PIC S9, P, V9, S, comp3. This is the most common and efficient COBOL type for decimal numbers. Map to DB2 decimal, P plus S, S, or numeric, P plus S, S. This is a direct and ideal one-to-one mapping. Example, COBOL PIC S9, 11, V99 comp3 maps to DB2 decimal, 13, 2. Example, COBOL PIC S9, 7, comp3 maps to DB2 decimal 7 0. Mapping binary comp for COBOL PIC S9 N comp. This stores integers in native binary format. S9 1 to S9 4 comp maps to DB2 SMALLINT. S9 5 to S9 9 comp maps to DB2 integer. S9 10 to S9 18 comp maps to DB2 BIGINT. Mapping floating point comp1 comp2 for COBOL comp1. This is single precision floating point. Map to DB2 real or float 24 for COBOL comp2. This is double precision floating point. Map to DB2 double or float 53. Handling null values between COBOL and DB2 COBOL has no intrinsic null concept. Fields always contain data, spaces for X, zeros for numbers. DB2 fully supports nullable columns. To handle nulls, COBOL uses null indicator variables. For every nullable DB2 column, define a PIC S9 4 comp field. Place it directly after the host variable in your data division. DB2 to COBOL, retrieving. If DB2 column is null, the indicator is 1. If not null, the indicator is 0 or 1. Check this indicator after select or fetch. COBOL to DB2, inserting, updating. To insert null, set the indicator to 1. To insert non-null, set the indicator to 0 or 1. Example: 05 W S emp phone null I N D PIC S9 4 comp. Conclusion: mastering COBOL data types is crucial. Understanding their precise mapping to DB2 is paramount. This knowledge ensures data integrity. It optimizes program performance and prevents common errors. Always choose the correct COBOL data type. Favor comp3 for decimal numbers. Use comp for integers to leverage mainframe efficiency. Diligently manage null values using indicator variables. This will help you build robust and reliable mainframe applications.